Welcome back to part 2 of Module 7, Lesson 4, where we continue to learn to write and solve multi-step equations. The textbook has laid out example 3 for us, as you can see here, but they just went boom and threw up all the supporting work all over the page without ever taking the time to slow down and show you what was happening. I am going to do that. I'm going to slow down and we're going to work these one step at a time as we go through the problem. Now, like the other ones we worked earlier, we're going to start off by using our distributive property. I'm going to distribute the 1/2 through the grouping symbol. 1/2 of 6x, that's going to give me 3x. 1/2 of -4, that's going to give me -2. And then that plus 6x comes down, the equal comes down, and now I have 12 times 1 6x. Well, let's look at that for just a second. That's actually -12 times 1 over 6. That would be the same thing as putting it over the 1 there, and we'd be simplifying and multiplying. And when you multiply that out, what are you going to get? A -2 over 1, also known as just a -2x. Plus, negative, actually it ended up being a minus here, a -12 times a +2, that's going to give me a -24. The next thing we're going to do, all the fractions are gone, makes it easier. We're going to combine these two like terms, the 3x and the 6x. I think y'all can probably hear Tilly the cat howling here beside me. 3x plus 6x, that's going to equal to 9x, and the -2, it's going to come down. Set that equal to a -2x minus 24. Now it's time to take and undo, or get the variable terms on one side, the non-variable terms on the other. I like to do it to where my variables stay positive, so I'm going to add 2x to both sides. When I do that, those zero out. 9x plus 2x, that's going to give me 11x. The -2 comes down, and the -24 comes down. Now we have to undo addition and subtraction, getting rid of that -2 by adding 2 on both sides. When we do that, these two zero out, leaving 11x on the left. On the right hand side, -24 plus 2, signs are different. Find the difference with the sign in front of your larger number going in front of the answer. Now we're almost done. We're going to take and divide 11 on both sides, here and here. Those 11's divide out, becoming 1. 1 times x is x. 22 divided by 11, that's going to be 2. Negative divided by positive is going to give us a -2. Jump back over to here, and we're going to take and put in that -2 for our answer. And, whoops, oh, I didn't check it. Dang it, hold on. And check it. And the problem checks. Therefore, once again, I guess you could check the same exact thing again. X is equal to -2. Why you wanted to put it in twice, I have no idea. But anyhow, that would be your supporting work for this problem. Now it's going to be your opportunity to work another one entirely on your own as you dive into extra example 3, which says that right there. Work on that. Now this problem's not going to be quite as easy as the last one, because that fraction is not going to disappear on us. When we work through it, we're going to find that 1/5 times 4x, that's going to be 1/5 times 4 over 1. Well, that's going to just equal 4 over 5. So we would end up getting 4/5 x for the first step. 1/5 times 20, that one will do better. 1/5 times 20 over 1. We can simplify. 5 goes into 5 once. 5 goes into 24 times. And that would multiply out to be 4 over 1, also known as just 4. So I got my plus 4 here. And then that plus 3x is going to come straight down. On the right hand side, 6 times x is going to be 6x. 6 times -3, that's going to be a -18. Now it's time to start combining like terms. So my 4/5 x and my 3x will add together to get 3 and 4/5 x plus the 4, and that's going to equal to the 6x minus the 18. Now we're going to undo addition and subtraction. We're going to work on moving our variable terms to one side and our non-variable terms to the other. But I have a little issue here. It's got a fraction or mixed number in it, and I really don't like doing those vertically, so we're going to do that horizontal. I'm going to do 3 4/5 x minus 3 4/5 x plus the 4 equals 6x minus 3 4/5 x, and then after that you have the minus 18. These zeroed each other out, leaving, oops, that should be a 4 right there, leaving positive 4 on the left, and on the right I've got 6 minus 3 4/5. We could rewrite that as 5 5/5 minus 3 4/5, where 5 minus 3 is going to be 2, 5/5 minus 4/5, that's going to leave me with 1/5. So now I can say I've got 2 1/5 x minus 18. Next step, add the 18 to both sides. I'm going to have plus 18 with those zeroing out, and that's going to leave me with 22 is equal to 2 1/5 x. From here we got to undo multiplication and division, which means dividing both sides by 2 1/5, but we know we can't divide by mixed numbers. So instead I'm going to convert that into an improper fraction. 5 times 2 plus 1 is going to give me 11/5 x. That'll be the first step of that. And then I'm going to multiply both sides by the reciprocal. That means it's going to be 5 over 11 is equal to 11 over 5 times 5 over 11x, with those dividing out, that 22 over 1. Then we're going to simplify. 11 goes into 11 once, 11 goes into 22 2 times. And when you multiply it out, 5 times 2 is 10, 1 times 1 is 1, 10 over 1, that's 10, x is equal to 10 is going to be our final answer. Jump back over to the answer sheet, and we'll put in our 10 right here, check the answer, and it checks. Easy math. And now we're getting to the really exciting stuff of translating word problems into those big complex algebraic expressions and then solving them. Let's take a look at what they have for us here. Coach Everly wants to order uniform shirts for all players on her women's lacrosse team. Each shirt costs $20. There's an additional cost for a player to put her name on the shirt. Every player on the team orders a shirt with her name on it. Now they say to choose a variable to represent the additional cost. I'm thinking C would be real good for additional cost. To put her name on the shirt, explain your choice, just did. And then what expression could you write to represent the cost in dollars for one shirt to receive, one player to receive one shirt? Well, my expression would be the $20 for the shirt plus C for the additional cost. And then from there, how would we do it for 2 players and 3 players? We just multiply that entire thing by 2 or 3. So let's see what they've got coming up next for us. Now we're going to take and do some of that voodoo math again, where your next one is you've got your 20 plus n. That's what I said at the beginning. 2 players would be 2 times the sum of 20 of n. 3 players would be 3 times the sum of 20 and n. 4 players would be 4 times the sum of 20 and n. 5 players will be 5 times 20 n, 6 players will be 6 times 20 n, 7 players will be 7 times 20 n, and 8 players will be 8 times 20 n. And check our answer. The answer checks. Easy math. From there, we could continue into this problem by saying, what's next? Let P represent the total number of players. So the expression P times the sum of 20 and n is going to represent the total cost for players to receive the shirts with their name on it. And finally, they've given us a couple of equations that we could use to represent the total cost for the players to have their names on the shirts. And the cost would be P, the number of players, times the sum of 20 of n and n. And if you distributed that P through it, you would have the total cost is equal to 20 times P plus P times n, or n times P. Carrying this in a little bit further, we've got 4 friends who bought zoo tickets, and spent $9.50 each for wristbands for zoo rides. The same day, a group of 5 different friends bought zoo tickets as well, and they spent $3 each on a stingray exhibit. The group of 5 friends also rented a locker for $8. If both groups spent the same amount of money, meaning the two sides are going to be equal, how much did each person spend on the zoo ticket? Well, if we looked at that one in words, you could say that the first group had 4 times the cost of the ticket and the $9.50 wristband is equal to the $8 for the locker plus 5 times the cost of a ticket and the $3 exhibit fee. The variables they decided was to let t equal the cost of the ticket, and from there that led into the equation that said 4 times the cost of the ticket and the rides on the left hand side equaled the $8 locker fee plus 5 times the cost of the ticket and the Stingray exhibit on the right hand side. This is where we're going to stop part 2 of this video. Come back in just a little bit for part 3, where we're going to work on this example number 4, involving a vegetable garden. We'll see you in part 3.